We tend to think that our world is pretty weird, like we've got giant floating chunks of rock and ice orbiting a ball of burning gas. And then there's life. But honestly, compared to the rest of the universe, Earth is pretty boring. There are worlds out there with more than one sun, planets made of pure diamond, and even alien planets covered in fossils. Today we're going to look at some of the strangest stars the universe has to offer, from an object so dense that a teaspoon of it weighs more than all the humans on Earth combined to a star powered by dinosaur bones. You'll never believe what's out there. Neutron star. We have mentioned neutron stars before. They're the collapsed cores of massive stars that have gone supernova. They're extremely dense and have powerful magnetic fields. The matter inside them is squished together so tightly that protons and electrons are forced to combine, forming a kind of soup of neutrons. A single neutron star can weigh around 2 times the mass of our Sun, but take up no more space than a single city. To make things even crazier, some neutron stars are actually pulsars, meaning they emit beams of radiation from their poles, like giant cosmic lighthouses. This happens because these stars rotate really fast. And if they're spinning more than 600 times a second, they also emit radio waves that can be picked up here on Earth. Scientists use pulsar timing to measure things in space, just like we used to use the stars for navigation. But those aren't the only special neutron stars. Some neutron stars are so dense that not even nuclear forces can hold them up. They collapse again and become even smaller than a regular neutron star. This makes them even denser, and although they're still incredibly tiny, they can pack more mass than a regular neutron star. These stars are called quark stars, and scientists think they may be made entirely of strange matter called quark matter. It's hard to imagine how something could be denser than a neutron star, but a single teaspoon of quark matter would weigh more than all the people on Earth combined. It's estimated that there are around 8 billion people who have ever lived on this planet, and the average weight of a human is around 62 kilograms. Now take the volume of a single teaspoon and multiply it by the density of a neutron star, which is about 1 billion kilograms per cubic meter. Then divide that number by the average mass of a human. That's how much a single teaspoon of a substance denser than a neutron star would weigh, and it's a lot. White dwarfs. They read the leftover cores of low to medium mass stars after they shed their outer layers of hydrogen and helium. White dwarfs are extremely dense. In fact, a single teaspoon of white dwarf material would weigh around 100 kilograms. That's heavier than a bowling ball. They're not quite as heavy as neutron stars or quark stars, but they're still pretty darn dense. In fact, white dwarfs are the most common type of stellar remnant in the Milky Way galaxy. And while they're relatively small, they can be very hot, reaching temperatures of up to 100,000 Kelvin. That's 10 times hotter than the surface of the Sun. But white dwarfs aren't just found in our galaxy. Astronomers have spotted them around other stars too, and they come in a range of masses. In 2012, researchers discovered a white dwarf that was more than twice as massive as our Sun. It's believed that white dwarfs can accrete material from their host star, causing them to increase in mass over time. So the most massive ones could be the result of several smaller stars merging together. Variable stars. Variable stars come in many different varieties, but they all have one thing in common. Their brightness varies over time. Some do it slowly, others rapidly. Some get brighter, others dimmer, and some pulse like a heartbeat. These stars are weird because their brightness isn't constant, unlike our Sun, and this is because their energy production isn't steady. For example, some variable stars have huge spots, like sunspots, but much bigger. As these spots move across the star's surface, they can block part of its light, making it appear dimmer. Other variable stars pulse as a result of non-radial pulsations, meaning they expand and contract in size, and some do it really fast. For example, the star V3944 Cygni pulsates around 1,700 times per hour. That's faster than any other known star. It takes less than half a second for the star to change brightness, which is why it's been nicknamed the lighthouse star. Red giants. Red giants are huge, luminous stars that are nearing the end of their lives. They read typically around 10 to 20 times the size of our Sun, and they glow with a reddish color due to their low surface temperature. But they're not just big and red, they're also very weird. For example, some of them have been observed to mysteriously brighten and then explode as a supernova. This is thought to happen when the star's core collapses, causing a shock wave to blast through the outer layers of gas. And while most red giants eventually become white dwarfs, others leave behind neutron stars, or even black holes. In fact, astronomers think that our solar system might have had a red giant around 10,000 years ago. If it had stayed on its current trajectory, it could have engulfed Earth and the other inner planets. Luckily, it passed by our way, and now it's back in the constellation of Scorpius. But that doesn't mean we're safe. Researchers predict that our sun will eventually turn into a red giant and swallow Earth. It's not expected to happen for another 5 billion years. So we've got plenty of time to pack our bags and head for the hills. Black holes. Black holes are perhaps the strangest objects in the universe. They're regions of space where gravity is so strong that nothing, not even light, can escape their grasp. And they're not just deadly for anything that gets too close. They can also be weird. For example, black holes can spin. And if they do, they create huge disks of glowing hot gas around them. This happens because material that falls into a black hole heats up to millions of degrees. This makes the disk of gas around a spinning black hole one of the brightest objects in the universe. It's called an accretion disk, and it is thought that the material in these disks can reach speeds of up to half the speed of light. But black holes don't have to be big. In fact, astronomers have discovered a black hole that's only about 130 miles wide. That's smaller than the width of the United States. But don't let its size fool you. Despite being just a few miles across, this black hole has a mass around 1,000 times that of our Sun. It's thought that this mini black hole could be the remnant of a massive star that went supernova. And while most black holes are solitary, some exist in systems with other objects, like stars or even planets. These objects orbit the black hole and provide a unique opportunity for astronomers to study them up close. One such system is called V404 Cygni, and it consists of a black hole around 10 times the mass of our Sun and a blue star around 30 times the mass of our Sun. The two objects orbit each other once every 40 days, and their system is only about 80,000 light-years away from Earth. These are just a few of the strangest stars in the universe, but there are many more out there waiting to be discovered. Who knows what other weird and wonderful objects we'll find in the vastness of space? Maybe one day we'll even find stars made of cheese. If you enjoyed this video, check out our other content. Thank you for watching.